Okay, so unfortunately I clicked the wrong button the last time and that's why the video stopped. But anyway, so what we did discover was that the second and third approximations were very correct, because the ratio, I mean, like 1 upon 625, that thing, that was like really small, and that's why we didn't need that many terms to approximate it correctly. But the first one, this guy, square root of 30, the problem was that, well, I did think that 1 upon 5 would be a very small number, so that should quite work out, but actually it didn't work out, and I also made a silly mistake. So because of both those reasons, the answer which I got was actually not very correct. So yeah, you can try it on your own and use like 4 or 5 terms, and then that will give you a very good approximation till 4 decimal places. So yeah. And I mean, like, if I was a computer, it would have been the best way to do it, because I would have uh, like a very efficient way of calculating stuff. I mean, calculating decimal expansions of irrational numbers. So that's the usage of this general binomial theorem, that you can do things which normally you wouldn't be able to do, like when you want to approximate square root of 5, you could either like do this by finding numbers which are squares of stuff, and like using inequalities and taking the square root and stuff. But you could also do it using the general binomial theorem, which actually gives you kind of a series expression for square root of 5, and then you can just approximate it by calculating the terms and adding them up. So that's a really nice way of doing this. I mean, at least for computer programs, it's a really nice way. Okay, so enough time spent. Let's move to the second question, I mean the sixth question, which is that if y equals to this expression 1 by 2 into 1 by 2 minus 1 by 2 into 4 into 1 by 2 squared plus 1 into 3 upon 2 into 4 into 6 into 1 by 2 cubed, and so on till infinity, then prove that 2y squared plus 4y minus 1 equals to 0. So, well, let's just deal with this equation first, and let's see if it gives us some kind of hint. So what that basically tells me is like y squared plus 2y should be equal to 1 by 2. So in other words, y plus 1 squared should be equal to 1 by 2 minus 1. um yeah, that looks like that. So what that gives me is like, wait, that doesn't make sense. 1 by 2 minus 1 is actually negative half, so it cannot be the square of something. So what did we do? Oh yeah, it's supposed to be plus 1 over there. Sorry for that. So that's like y plus 1 is equals to the square root of 1 plus 1 by 2. So what would happen if I actually expanded this thing using the general binomial theorem? So it's going to be like 1, it's like 1 plus 1 by 2 raised to the 1 by 2 power. And yeah, you do see that over here the difference is of 2 everywhere, so I think it would be correct to say that it should have like 1 by 2 as the power. So let's see what happens. It's going to be like 1 plus so it's going to be like 1 by 2 into 1 by 2, then it's going to be 1 by 2, and then minus 1 is like 1 by 2 into minus 1 by 2, so that would be negative, unfortunately. Hey, that's not correct. That shouldn't be like that. Wait, so what now? Yeah, okay, this has got to be 1 by 2 over there. No, it's actually negative over there. So cool, that's gonna work. So this is going to be minus minus 1 by 2, and then you got um I think negative 1 by 2, so it's like once again 1 by 2, that thing upon 2 factorial and 1 by 2 squared. Yeah, that looks correct. It's like this 2 factorial can be written as 2 into 1, so that would make it like 1 upon 2 into 4. And then what else? So you got these things like 1 by 2, and then you got minus 1 by 2, and then minus 3 by 2, that thing upon 3 factorial, which is like 3 into 2 into 1, and then 1 by 2 cubed. So over here, what is like, okay, there is in fact that 1, 3 and 5. Wait, what? Which question was that? Sorry, there's actually that 1 and 3 on the top, and okay, but yeah, that would be, it's like 1 and 3 on the top, and then 2, 4, 6 in the denominator. So it's just this thing multiplied by 2 every time. So these 2's in the denominator, that's going to actually turn this into 6 into 4 into 2. So this is 1 into 3, then you got 2 into 4 into 6. So now you see the pattern that all the denominators in the 2 of that upper part, that's going to turn the lower part into this thing. So the 2 into 4 into 6, then 2 into 4 into 6 into 8, and so on. It's like the factorial thing, but every term is multiplied by 2. And on the top you're going to have this odd number stuff like 1, 3, 5 and stuff, and it's going to be an alternate plus and minus over there. So it's like minus and then plus, and once again you get a minus, and so on. So yeah, and that looks correct. So y plus 1 is this thing. So what that means is that y is equal to all this stuff over here. So yeah, that's correct. So what this means is that this identity is obviously true. Identity, no, well, whatever. So yeah, that's correct. This series was nice. Okay, let's go to the next question then. Okay, so find the sum up to infinity of the following. So let's just do the first question, and then I will do the second and third in the next video. Okay, so sum up to infinity of the following series. So let's just see if there's some pattern over there. 1, then 1 upon 3, then 1 upon 3, and 3 upon 6, and then they got 3, 6, 9. Oh, so you can see there's like the factorial thing over there. So it's like 3 into 1, and then 3 into 1, and then 3 into 2, then 3 into 1, 3 into 2, 3 into 3 over there. So what that gives me is like got that 3 power. Oh yeah, that will be nice. So yeah, here's how it should be going. So it's like 1 plus, I'm going to add an extra 2 over there. Well, that should be okay. Yeah, so I'll just take that 3 out, and yeah, should I add a 2 over there? I don't know. So it's gonna be 1 upon 3 into 1. Then you got 1 into 3 upon 3 squared into 1 into 2. Alright. So it definitely looks like this is going up by 2 every time. Right? But that doesn't quite make up it. Oh yeah, that could be okay. So now I got it. So it should be something like the following. So like 1, and then you got 1 by 2 over there. Okay, and this thing upon 1 factorial, and then you got 2 by 3 raised to the first power, right? And then plus you're going to have 1 upon 2, and then 3 upon 2 over there. That thing upon 1 into 2, which is like 2 factorial. Okay, 2 factorial, and then you got 2 by 3 raised to the second power. Then similarly you will be having 1 by 2, and then 3 by 2, and 5 by 2 upon 3 factorial, and 2 by 3 raised to the third power, and so on. So yeah, this was easy. So this is going to be like 1 minus 2 by 3 raised to the I think negative 1 by 2 power, right? So that's gonna work. Yeah, that definitely works. So this is going to be equal to 1 by 3 raised to the negative 1 by 2 power, which is going to be 3 raised to the 1 by 2 power, which is like square root 3. So yeah, that was nice. Okay, so I will see you in the next video, and in the next video we will do these two questions. Okay, cool. Thanks for watching.